Good morning, awesome Niners. Right, buddies, we get to keep cracking on today in our standard form unit. It's another cool lesson today. It's calculations in standard form this time. I don't get to talk to you about, oh, drought, what's just happened there? I don't get to talk to you about all of the exciting reasons for standard form today, but we're just going to get a lot of chance to practice, and I think I have a really good activity for you that I hope that you will enjoy at the end. So my goal is for this video not to be super duper long, but for you guys to get the idea behind it anyway. So here we go, calculations in standard form. Now, pretty much, buddies, I wrote it out as steps, which is unusual for me, I have to say, to actually write it in step format. But here's what you're going to do. Timesing and dividing in standard form is not bad at all. It's quite a nice and easy thing to do, actually, to times and divide. Add and subtract is a little bit harder, so it's a bit like fractions that way, that timesing and dividing fractions is easy, but adding and subtracting them is a bit harder because of the common denominator. It's a bit like that, that times and divide's a bit easier with these, so let's see what we do. Let's try some, buddies. Cool. So here's what you're going to do. Always start off by just multiplying or dividing the big numbers first, and then work out the power second. That's pretty much it, lovelies. So I'm going to show you on this first question here just how to do it. I don't think you'll need maybe all of the questions that I'm going to show you to get your head around it, but we're going to just make sure you do have your head around it first. Okay, so here's how it goes, buddies. To start with, what I mean by the normal numbers is like the 3 that's in this one and the 2 that's in that one. You don't even need the brackets around them, to be honest. I put the brackets around them just to really show that this whole thing here is the first number you're timesing by, and this whole thing here is the second. But as you guys know, you can times in kind of any order that you like, so you don't actually need the brackets, but I put them to show you. Right, so anyway, these are the normal numbers, the 3 and the 2. And all you're going to do is you're going to do this. You're going to go 3 times 2, simply giving you 6. Okay, so that's the part that matches up with just the normal numbers, if that makes sense, buddies. Now the second thing you're going to do is you're going to work with the powers. We're actually going to use our index laws here, buddies. So here is the 2 numbers with powers. We have a times 10 to the 6 here, and we've got a times 10 to the 5 there. Well, using your index laws, my buddies, you know that when you times 2 index numbers together, what is it that you do with the power? Or in other words, say I gave you an easier question. Say I said, what is x squared times x to the power of 4? Well, what would that simplify down to, buddies? Well, if you said x to the 6, you're dead right, because when you times powers together, when you times numbers that have powers in them together, you end up adding the powers. And that's the same deal here. So it's just a 10 to the 6, because we've already done the blue part, and the yellow part, it's a 10 to the 6 times 10 to the 5. What's 10 to an It's 10 to the 11. And that is literally it, my buddies. You are doing calculations in standard form. Oh yeah! Okay. Now I wish that was only just it, but it does get a little bit harder. So here we go, a little bit harder. Okay, same deal again. Start with your normal numbers. What are we going to write down first then? Well, if you said, well, first of all, what we're going to do is we're going to times the 9 by the 8, you'd be right. And 9 times 8 is 72. Now what are we going to do with the powers? Well, what we're going to do with the powers, always just times here as well. What we're going to do with the powers is we're going to add them. So we have a 10 to the minus 5 and a 10 to the minus 11. Now they're multiplied together, which means you bodge them together, you add them together. So it's like minus 5 plus minus 11, or just minus 5 minus 11. And that's minus 16. And that's what you get. Now, I want you just to have a minute to look at that answer, 72 times 10 to the minus 16, and say to yourself, is that actually the final answer? Is it right? Well, no, it isn't. There's a problem. What's the problem? That's it. Yeah, okay, good. So I hope some of you spotted it. The problem, you see, is the first number 72. Now, is that allowed to have a 72? No, it isn't actually. It's got to be 7.2, okay? Times 10 to the something. It's got to be 7.2. You're allowed one digit in front of the decimal, and then whatever else there is goes after the decimal. So here's what I'm gonna say, and here's the hardest part of this whole lesson. Here is how I would suggest you do it. We needed the 72 to be a 7.2. So what you did is we've just essentially made the 72 10 times smaller. Okay, 72 is 10 times smaller to get to 7.2, which means 10 to the minus 16 to balance that out, because this was 10 times smaller, it's going to have to be 10 times bigger. Okay? Now 10 times bigger when you're dealing with powers of 10 means that you're just going to increase the power by 1. So instead of it being minus 16, we're going to increase that by 1, which is minus 15. Not minus 17, even though that number looks like it's bigger, but minus 15 because it's less cold, right, when you're dealing with negatives. And that's it. That's the final answer, okay? This had to be 10 times smaller, so to balance it out, this had to be 10 times bigger, okay? And that's pretty much it. Just like, yeah, well, that's pretty much it. I won't try to confuse you. That's perfect. Cool. Here we go. Same deal again, but this time it's division. So here we go. Start with your normal numbers first. 8 divided by 4 makes 2, of course. And now times 10 to the power of, and here we go. 10 to the power of 4 divided by 10 to the power of 2. Now, I'm not sure if you remember, I hope that you do, but what is it that you do when you divide numbers with powers? Well, if you add when you times, what will it be when you divide? If you said subtract, you're absolutely right, my buddies, it's a subtraction. So it's just 4 take away 2, and that just makes 2. Is that in standard form? Yep, absolutely it is. Perfect, because it's just a number on its own times 10 to the power of something. Cool beans. D's tricky. I think you should do D all by yourself, though. So have a little go. Go. Okay, and you're back. So let's see how you've got on. 12 divided by 3, well, that's going to be 4. That part shouldn't have been any trouble. But then here's where it gets a bit tricky. It's just with those negative numbers. And I know that you've practiced them ever since year 7, but people still kind of don't like them all the time. Remember, we're subtracting powers, buddies. So this is going to be 6, and because it's divided, we're going to take away. So this is 6 minus minus 5, which is the same as 6 plus 5, which is 11. Cool beans. And the final one, my buddies, is this. If times and divide works, then certainly powers work, because powers are just repeated times and divide, aren't they? Like 3 to the power of 3 is 3 times 3 times 3. So yeah, this is just repeated multiplication. So definitely this is going to work too. And it works the same as the others. Whatever the number is out front, it just goes like normal. So all you're going to do is literally 9 squared, which makes 81. Cool beans, buddies? Now, do you remember what the rule is for power of a power? Like, what is it that we do when we have power of a power? So if you had x cubed squared, what did that equal again? Well, if you said x to the 6, you're absolutely right. Absolutely right. So here we go. 4 times 2, 8. It's 81 times 10 to the power of 8. Now, is that right? Is that the final answer, buddies? If you said not quite, if you said it's not quite, dead right again. This is too big. It's got to be 8.1. Okay, you're only allowed 1 digit before the decimal point. So what we've done is we've made this 10 times smaller, which means to balance it out, this has to be 10 times bigger. So we increase the power by 1. 8.1 times 10 to the 9, like an absolute boss. Believe it or not, my lovelies, at only 9 minutes into the lesson, that's all you have to learn today. So here's what I'm going to get you guys to do. Please have a look at this just here. There's 2 things I'm going to get you to do. The first is still in the video. So right now, I'm going to tell you an activity in a moment, but right now, just have a look at what's on the screen, pause the screen, and then see if you can get every single answer to all of these. I will take them up with you in just a moment. So you really do need to do this, so don't wait for me. Push pause and then start doing them. You ready? Pause. Okie dokie, and you're back, buddy buddies. So let's check you got it right. First one, my buddies, is going to be 8 times 10 to the power of 11. Second one, buddies. 6 times 1.6 times 1.5 is actually 9. Add the powers times 10 to the 8. See, you do get in the hang of it. I'm not going to lie. It does become very quick soon enough. Ooh, it's a two-stepper, this one. Okay, 4 times 3 is 12. And then this is going to be times 10 to the power of minus 2. This is not standard form, so we have to switch it. 1.2 times 10 to the power of. We made that 10 times smaller, so we're going to have to make this 10 times bigger. Increase the power by 1. Minus 1. Cool beans. This one here, 8.6 divided by 2 is 4.3. It's a division, so we're going to subtract the powers. Times 10 to the power of minus 5. Here we go. 1 divided by 4. Oh, it's a good one. 0.25 as a decimal. 1 divided by 4 is a quarter, of course, and then that's 0.25. And we're going to subtract the powers. 12, take away 3 is 9, so it's times 10 to the 9. Okie doke. Still not in standard form. It's got to have 2.5. The first number in front has to be like a non-zero digit. There's allowed one digit that isn't 0 in front. Cool, cool, cool. So how do we fix this? We made this 10 times bigger to turn 0.25 into 2.5. We went 10 times bigger. So we're going to have to make this 10 times smaller. So if we're going to make times 10 to the 9 10 times smaller, it's times 10 to the 8. You reduce the power by 1. And final one, buddies. 7 divided by 7 is 1, of course, times 10 to the power of minus 9 minus minus 5. Minus 9 plus 5 makes minus 4. 1 times 10 to the minus 4. Now, in theory, this is just the same as 10 times... in theory, this is just the same as 10 to the minus 4, but I'm leaving the 1 times in front of it just to show that I knew it was standard form. Cool. I hope you got the power ones right as well. Let's see. 2 squared is 4, and then you multiply the powers times 10 to the 5, and that is in standard form. Job done. This one here, 5 squared is 25, and you times the powers. Minus 5 times 2 is minus 10, so there we have it. Not in standard form, though, so 2.5 to get it so that the decimal is after the first digit. 2.5 times 10 to the power of, and we got to work it out. This became 10 times smaller, so to balance it out, this becomes 10 times bigger, minus 9. Cool. Add 1 to the power, which is minus 9, because it gets warmer if you think about it as cold versus warm numbers. Cool, cool, cool. And here we go. 4 squared, 16 times 10 to the 12. No problem. 10 times smaller, 1.6. So 10 times bigger, 10 to the 13. And the last one here, 49 times 10 to the minus 16. That's too big. 10 times smaller, 4.9. Make this 10 times bigger, 10 to the minus 15. Not minus 17, minus 15, because it gets warmer. Cool. So that's just a standard old worksheet style practice. It does the body good to do that, though, my lovelies. It's important that you can do some basic ones out of just a worksheet, because here I've got a cool fun activity for you. This is a bit tricky if you don't know how to do it, so I'm going to make it, I'm going to simplify it for you a little bit, okay? Essentially, it's just match 3, okay? So there's 3 of a kind a whole bunch of times in here. So for instance, maybe it might be something like A, C, E, and this one might be like B, F, I, or something like that, if they all matched, if they were 3 of a kind. Get me, buddies? Okay, it's a bit of a palaver though. It's a bit hard to do this if you don't know the shortcut way of doing it. Lots of people are inclined to say put the A there because that's the first one, and then to like go through and try to find things that are the same answer as A, and that's usually how people do it. So you'd be like, okay, that's not the same as A, so I'll give it a miss. That one is not the same as A, so I'll give it a miss, and so on and so on. That's usually what people do, and they go through and check each one against A. Now, because I want you to actually have a little bit of free time tonight, I'm going to give you a bit of a tip, okay? It's my pro Mr. Wade patented strategy tip. Here's what I would say. If you want to make this quick as can be, which I would if I was you, I'd want to enjoy it, make sure I understand, but I would also want to make it quick, so I'd want to learn lots, but I wouldn't want to waste tons of time. Here's what I'd suggest. Can you see that this is in standard form? And you know the activity that I'm trying to get you to do is to understand standard form, right? Okay, we can do 2 things at once. We can shortcut this activity, and you can prove that you're good at standard form. Here's how you do it. put them all in standard form before you even try to match them. That's what I'd say. So A is already done. It's already in standard form. This one here, though, it's not in standard form. It needs to be 8.4, right? Got me, my buddies? It's got to be 8.4. So we've made that 10 times bigger, so we'll make this 10 times smaller. So that's just times 10 to the 1. That's in standard form now. This one here, this is going to be 8.4 because it's not in standard form. We've made that 10 times bigger, so we have to make this 10 times smaller. So it's actually times 10 to the power of 0. Now, I don't know if you guys remember this or not, but it's, yeah, times 10 to the power of 0 is actually just like times nothing at all. Anything to the power of 0 is 1. So this is just 8.4. Now, I don't want to do them all for you, but you saw how quick I did those 3, right? So I'm not going to do them all for you, though, because I think this is enough to point out what you're supposed to be doing. So if you check it out, can you see that this one was just equal to 8.4? Like C was just equal to 8.4? Well, is there any others that are just equal to 8.4 somewhere? Yeah, down there. See that? C, T. And is there another one equal to 8.4? Probably, but we're going to have to go through and find it. Cool beans, guys? So do you get how it works? There's another one here that also equals 8.4, but we just haven't found it yet. And then all of them will have a match until this entire grid is filled in. So I hope you get it, my buddies. That's what I want you to do. And again, I promise I'm not just trying to make you do all the practice correctly, but the easiest possible way of doing this is to put them all in standard form, okay? Look at here, I'll even do one more for you just to show you how quick and easy it is. See, I almost want to finish the whole sheet right now. I almost want to treat it like a race, even though I shouldn't. Here we go. So this would be like 8.04, right? So we made that 10 times bigger. We'll make this 10 times smaller. So that's 10 to the 0, which is just the same as 8.04. And look, is there another 8.04 somewhere? There will be. 8.04 somewhere, maybe? I can't see it. Oh, yeah, it's J. So look, there you go. D matches with J, and there'll be another one that matches there as well. Yeah, anyway, I need to stop myself because I'm going to do the whole sheet if I don't slow down. So what I want you to do, buddies, is send me a picture of all of your awesome work. So this sheet completely completed with the answers in standard form written underneath each one, and all of this bit completely completed, and show me that you did this as well. Okie doke, buddies. And that's it from me. So have a really lovely day. Really good work, my epic Niners, and see you next time. Bye, buddies!